Okay, so today we're going to talk about graphing systems of linear inequalities. And the nice part about this topic is, for this topic, you literally can only graph these systems to solve them. So in any systems of inequalities, you can only graph to solve them. So you don't have to worry about substitution, you don't have to worry about elimination. And we can tell these things are inequalities by the inequality symbols that they have. So you can see they have inequality symbols, definitely inequalities. Let me choose two colors for these lines. I'm going to choose red for this one. And let's choose purple for this line, if I can grab it. And we'll graph these things. So if you remember from before, graphing an inequality is very similar to graphing an equation. You start with -4 on the y-axis for your y-intercept. I'll start going up 2 and over 1. Up 2 and over 1. And I can do it one more time. And this symbol will tell me that I have an open line or that it's dotted. So I'm going to dot a line because it doesn't have anything underneath it, so it's dotted or open. This symbol also will tell me that x, or the shading that I should do is bigger than the line, because y, this thing over here, is bigger than the line. Click you for a second. So the y is bigger than the line. So if I go over here, I would shade above, or bigger than the line. So here's my shading above the line, shading above the line, shading above the line. So that's what it should look like. Now let's graph the line in purple. This one would start up at +2. Whoops, +2, can't count. 1, 2, don't need that dot there, so and then I'm going to go down 1 and over 2 to the right. And down 1 and over 2 to the right. Or if I go reverse, up 1 and 2 to the left. Now I would draw a solid line for this. Because of the underline sign in this one, because this is a closed. And this would shade below, because y is less than the line, so it's shade below. Now the answer for this problem is where the shading meets. So the shading meets right in here, in this section, the green. It's where the red meets the purple, so this shading that I make green is the answer to this problem. It's where the two colors kind of meet together. That's your answer. It's an area this time instead of like a single point. It's a lot of points anywhere in this region is your answer. So let's solve the second part of this thing. And the second part of this thing I think is actually a little bit harder than the first part, because this time we're going to be given a graph. And we have to think what the answers could be or would be. So first thing I'm going to do is I'm going to find the equation of this line. You know an equation of the line is going to have something like this. Y equals mx plus b. So we have to kind of fit in all the different things. So the slope of the line, well, it looks like the y-intercept of this line is 3. And it looks like the slope of this line is up 2 and over 1, 2, 3. And this line is a solid line. Since it's a solid line, that means it's equal to. And I know it's greater than because it's kind of shaded above. So we have one equation of the first line is y is greater than or equal to 2/3 x plus 3. Now let's find this other line. I can see from this other line, that again if I kind of do the same setup, that its starting point is down here at -3. And I know from this that I should take my slope and go up 1, 2, 3, 4, and over to the left 1, 2, 3. So its slope would be up 4 and over -3. And that would be y. Well, this line is dotted, so I won't put an underline, and it is also shaded above, so it's just strictly greater than. So those would be my two equations of my line, this one right here and that one over there. Now sometimes these are both in what we call slope-intercept form. But sometimes they don't give us things in slope-intercept form. Sometimes they give us things in standard form. So if something's in slope-intercept form, sometimes we need to get it into standard form. And this is how we'd go about doing it. Standard form has the x and the y on the same side, and it equals something. So for this one, my x right here is on the wrong side, so I'm going to add or subtract 2/3 from both sides. And that would give me that y minus 2/3 x is greater than or equal to this +3. The other thing that you don't like to have most times in this case is you don't like to have a fraction. So how I get rid of the fraction is I would multiply everything right here by 3. Because multiplying by 3 will cancel out this fraction right here. And I will be left with my final answer, which is 3y minus 2x is greater than or equal to 9. That would be one line equation. Let's try to do the same thing with this line over here. I'm going to start out, try to get this x to the other side, so I'll have y. And since this is a -4/3, I'm going to add it over. So we're going to add 4/3 and add 4/3. When I add it over, whoops, I should have this right here. And then again, I'm going to want to get rid of that 3. So we're going to multiply everything by 3. So this would give me 3y plus 4x is greater than -9. So that would be the equation for this in standard form. So the big thing for graphing these is first make sure you can write things in slope-intercept form. After you've written things in slope-intercept form, if it gives you answers that are in standard form, convert the things from slope-intercept form to standard form.